All right, guys, welcome to lesson 11.4. Today we're going to solve trig equations that have outside operations. So, for example, we've solved problems like this already using the unit circle. Last time we did it with calculators, but we're going to go back to using the unit circle to solve for this lesson. But we solved problems like this already, but now we're going to have problems that look more like this, stuff where there's extra stuff going on. So it's not just your trig function is equal to a number anymore. You've got our trig function is being multiplied by 2 and subtracted by 1, and it's equal to a number, or something like that. So basically we have outside operations in addition to just the trig ratio. So here are the steps that we're going to be using for today's stuff. The first thing we're going to do is we're going to get the trig function by itself. We're basically going to get rid of all those outside operations. Once that's done, we're going to solve it like usual. So it seems pretty simple. A couple of things that we want to keep in mind, though, as we do this is sometimes you'll have more than one trig function in there. You might have two sines or two cosines or something like that. When that happens, we're just going to combine them together into one. Another thing to keep in mind is that sometimes we'll be solving by taking square roots, and when you do that, you get a plus and a minus outcome. And when that happens, that means that there's actually going to be twice as many answers as usual, because the plus and minus will double the number of answers that we get. So that being said, let's go ahead and jump into the lesson and see what these things look like. All right, so here's example number 1. It says use the unit circle, in other words, no calculator, to solve this equation for all angles between 0 and 360. All right. So the first thing we want to do is we want to get the tangent function by itself. So you'll notice that we have two tangent functions here. The first thing I'm going to want to do here is I'm going to want to combine those tangent functions together. So I'm going to subtract 3 tangent on both sides like that. Now those cancel out, and then we have 6 tangents plus 3 tangents. That makes 9 tangents. And now it just equals -4. So the first thing we did was we combined our tangents. Now you may have to do that at step, or you may not. It just depends. Do you have 2 trig ratios or not? If you do, then combine them. If you don't, then just move on to the next step. The next step is to get the tangent by itself. So I want to get this all by itself, which means I need to get rid of this 9, and I need to get rid of this 4. The first thing we're going to do is we're going to get rid of the number that's being added or subtracted to the tangent. That's this guy. And then after that, we'll get rid of the number that's multiplying the tangent, which is the 9. So I want to get rid of the 4 by adding 4 on both sides. And that just gives me 9 tangent equals 0. And then I'm going to divide both sides by 9. And 0 divided by 9 is still 0. And at this point, so there's the next step, basically, is get tangent by itself, or get the trig ratio by itself. After that, we're just going to use our unit circle, and we're going to solve like usual. So since this is tangent, we would want to look at the tangent unit circle, and we're going to find where on the tangent unit circle, what angles give us a tangent value of 0. And there are 2 of them on there. One of them is 0, and the other one is 180. And so there's our answers. Okay. You could also write them as radians if you want to, 0 and pi, but this is good. All right, let's go ahead and take a look at 2 more examples before I let you guys practice. Number 2. This looks really ugly, so bear with me here. I'll show you guys the steps. The first thing you want to do if you have fractions is get rid of the fraction by multiplying everything by the denominator. You may want to take a moment and write that down on your notes. But if you have fractions, multiply every term by the denominator in order to get rid of the denominator. So my denominator is 4. I've got 2 denominators, but they're the same. So I only need to multiply by 4. Now, I don't know that this will happen, but if you come across an equation with two different denominators, then you may very well have to multiply by a denominator twice. It just depends. If you multiply it by it once and the denominators go away, great. If it doesn't, then, well, we've got to do it again. So I'm going to multiply everything by 4 all the way across. So let's do that. First of all, I'll multiply this piece here by 4. And what's going to happen is you can think of that as this whole thing being multiplied by 4, and then these cancel. So all you're left with is just 8 plus the square root of 2. Okay? Let's continue. Now I'm going to multiply this by 4. Negative 2 times 4 is negative 8. Multiply this by 4, and I'm going to get 8. Multiply this by 4. When you do that, the 4's cancel. And I'm just left with 7 now. All right. Next thing we want to do is we want to get the secants together. So I'm going to add 8 secant to this side. I could have also added the 7 secant. It doesn't matter. That gives me 8 plus the square root of 2 on this side now. And 8. All right, negative 7 secants plus 8 secants leaves me with 1 secant, a positive 1 secant. We really don't need to write the 1, and so I'm going to go ahead and delete that for now, but negative 7 and positive 8 makes 1. All right, next I'm going to subtract 8 on both sides. And I'm left with square root of 2 equals secant theta. Now from there, we're going to solve like usual. So this one had the same steps as the last one, except it had this extra step in the beginning where we got rid of the fractions. So if you have fractions, start by doing that. But after that, the steps were the same. Combine your trig functions if you have more than one, and then get the trig function by itself. And now we're ready to solve it like we have in the past. So we now have secant theta equals the square root of 2. How did we solve that in the past? Well, we took the reciprocal on both sides, and we rationalized if necessary, which it is in this case. And then from there, we can use our unit circle. So where does cosine of theta equal square root of 2 over 2? There are 2 places. So we're looking for where on the unit circle is our x value equal to radical 2 over 2. What angles does that happen at? They happen at 45 degrees, or if you want to say pi over 4, that's fine for radians. And it also happens at 315 degrees, or if you want to say 7 pi over 4, that's fine as well. Okay, so there it is. All right, so I thought I was going to do 3 examples, but I only had 2, and that's probably enough. I think we have enough now to let you guys give it a try. So we're going to call this student practice 1. So go ahead and solve numbers 3 and 4 here, and pause the video. And when you unpause it, you will see the solutions. All right, so for this guy, we should have gotten 45 and 315. And for this guy, we should have gotten 150 and 210. If you didn't get those, go ahead and rework it and see what you get. We're going to move on to our next set at this time. Same directions, same idea, but we're going to call this example 2 because there's something a little new that happens here on this one. You're going to notice that my trig functions have a little square there. Now just so you guys know, as a nice little side note, and I would encourage you guys to write this down here somewhere, if we ever want to take a sine function and square it, the way that we write that is like this, typically. We put the square next to the sine. So what does this mean? This means we're plugging an angle into sine, and then we are finding the sine of that angle, and then we're squaring the result. And this thing means the same thing. But if you ever write this, that is different. Okay, and I want you to notice the difference. How does this expression differ from this one? Take a look at that. It's where the square is located. On this one up here, the square is right after the sine. And this one down here, it's on the theta. In this case, this means you're squaring the angle and then you're taking the sine of it. This one up here means you're finding the sine of the theta first and then you're squaring it. So it's a different order, okay? Now these two look a lot alike, the one on the left and the one down here. But what's the difference? Well, this one's in brackets, which this means the same thing as this one over here. Both of these mean you're plugging the angle in and taking the sine first, and then you're squaring it. This one down here means you're squaring just the angle first, and then you're taking the sine of that result. So make sure that you know that these two things are equal to each other, and this thing is different. Okay, now, to be honest, you won't be seeing much of this anyway. I just think it's important you guys know that what these things mean. Now, how big of a deal is that for now? Not a huge deal. I just want to make sure you guys know it can make a little bit of a difference in some things that come up later. So make sure you know the proper notation. All right, so that being said, let's go ahead and get started. So no fractions, so I don't have to get rid of any fractions here, but I do have sine squareds on both sides. So I'm going to start by putting those sine squareds together. So that goes away. And on the left, we're left with 4 sine squared theta. Okay. Now we want to get the sine squared theta by itself. So the first thing we're going to do is we're going to add this 4 over there. That leaves me with 4 sine squared theta equals 3. And then I'm going to divide both sides by 4. And that's going to leave me with sine squared theta equals 3/4. And now we're going to square root the left side and the right side. Now when we do that, you have to remember to give this a plus and a minus. Now the square root of 3 is just the square root of 3, but the square root of 4 is 2. So we have two answers here. I've got sine of theta is equal to the square root of 3 over 2, and I have sine of theta is equal to the negative square root of 3 over 2. And both of those are going to give me 2 answers. Okay, and so ultimately I'm going to end up with 4 answers. So since we're dealing with sine, sine tells us the y value. So where at on my unit circle does the y value equal radical 3 over 2? There are 2 places where that occurs. One of those is at 60 degrees, and the other one is at 120 degrees. Now let's solve the other one. Sine of theta is equal to negative radical 3 over 2. That means we're looking for where the y value has a negative radical 3 over 2 there. And that happens in 2 places as well. That happens at 240 degrees. And it also happens at 300 degrees. So we actually end up having 4 answers. And that's because when you take a square root, you get a plus and a minus, which means that you get 2 equations as a result, which means that you get twice as many answers. So we have 4 answers this time. All right, so let's review. Step 1, put your trig functions together. Step 2, get the trig function by itself. Step 3, solve like usual, but in this case, remember, when you take a square root, you get a plus and a minus, therefore 2 equations, and therefore twice as many answers. Let's go ahead and do another example. Here we go. Just for the heck of it, why not do another one? I did it again. Actually, I'm just going to count this as a student practice, not as an example. So student practice 2. So go ahead and pause the video here. Give it a try. When you unpause it, I'll have the answers available. All right, you should have gotten 45, 135, 225, and 315. Okay, so if you didn't get that, take another look at it, rework it, see if you can get it figured out. And we're going to go ahead and move on to our last set for the day. So for our last set, we're going to solve these funky looking equations again, just like we have been all day. But this time, instead of using the unit circle, we're going to go with the calculator approach and round to the nearest degree. Okay, so let's go ahead and begin. So step 1 is to put your cosines together. You'll find that most of the steps are the same. It's just when we get to that last step where we have to solve like usual, this one will be different than the others. So now by adding cosine on both sides, we get that. Next, I'm going to go ahead and subtract 4 on both sides. And I'm just going to use my calculator for that. I'm just going to figure out what is 2.24 minus 4. And I get negative 1.76. Next, I'm going to divide both sides by a negative 2. So those go away. And when I divide 1.76 by 2, I get negative 0.88. And then from here, we're ready to go ahead and solve it using our old methods. So if you forgot how to do these, you might want to look at your 11.3 part 1 notes. The first thing we do to solve for theta, in this case, instead of looking at the unit circle, is we're going to take arc cosine on both sides. Oops, didn't write cosine. There we go. And we're going to let our calculator do that for us. So let's type that into our calculator. As a result, I get theta is equal to 152 if I round it to the nearest degree. That's how you find one of your answers, but we need to find the other one. And to do that, we're going to draw a picture and use symmetry. Now, once again, if you look back at 11.3 part 1 notes, after you sketch your angle, which would be about right here is where 152 degrees is at, what we learned in that lesson was that for cosine, the matching angle or the symmetrical answer that goes with it will always be downward from the original. So that will be here. So I need to figure out what that angle is. And every problem's a little bit different in order to pull that off. Okay, but here's what I know. I know that, I'm going to trace it here in purple. I know that this angle here is 152 degrees. And therefore, this little piece over here, which I'll make green, would have to be a 28 degrees. And the reason for that is because I know that 152 plus this angle has to make 180, and that would be 28. And because of the symmetry, if this angle is 28, then the one directly below it is 28. And then basically we can add all, to find the red arc, we do the purple plus the green plus the brown. And that'll give us our other angles. So we have 152 plus 28 plus 28. And we get 208 as an answer. And there's our other angle. Okay, so you're going to need to look at either 11.3 part 1 or 11.3 part 2 notes in order to solve these calculator-based questions. So here's one for you guys. So go ahead and, yours is cotangent, and we talked about that one in the 11.3 part 2 notes. So you might want to look at that if you need help. But go ahead and pause the video here, give this one a try, and when you unpause it, you will see the solutions. All right, guys, so there you have it. You should have gotten 348 for the first angle, 168 for the second one. All right. I'll go ahead and work this one out just in case you had a hard time with it, because this one might be a little bit harder. First of all, I would minus the cotangent on both sides. Which gives me this new equation here. Then I would add 2 on both sides, which would give me this new equation. And then I would take the reciprocal on both sides. And for that one, what do we get? Let me see here. I get negative 0.213. And then I would arctan both sides. And at that point, I would get theta equals negative 12 degrees. But we don't like that, so we add 360 to it. And from that, we get our first answer, 348. Okay, then from there, we use the symmetry that's associated with tangent and cotangent to find our second answer. So we're going to need to draw a picture. 348 degrees would be probably somewhere like right about here. I'll draw my 348 degree angle there. Now, as we already know, this little piece up here is 12. And we know that for tangent, the other one that matches it will be diagonal to it, so it'll be somewhere over here. So if this angle is 12, then this angle will be 12. And so basically, to find the measure of this second angle, it goes to here. We're going to do, it's basically 180 minus 12. And so there's our other answer, 168. Okay, so that does it. We'll see you guys in class to practice this stuff. Till then.